The best way to see how AutoML vision and natural language work is through live demos. Let's start with vision. To show you AutoML vision, we'll look at a model I've built for predicting the species of a leaf given an image. The data for this is sourced from the leaf snap dataset, and our model was trained on images of 10 different types of leaves. Here, in the AutoML Vision UI, is where I gather and label all of the images that will be used to train my model. I can upload them directly to the UI, and I only need 10 images per label to start training. The best part about AutoML is that I don't need to write any of the model code to train this. I can simply press the train button to train my model. This particular model took exactly 1 hour to train. When training completes, I can take a look at metrics to evaluate accuracy. This is what's called the confusion matrix. It tells us the percentage of images for each label that our model was able to classify correctly. Ideally, we'll see a strong diagonal down the top left, since this means our model classified a high percentage of the images in our test set correctly. And we can click on any cell to see the specific images where our model got confused. Finally, the most important part of this process is generating predictions on images our model hasn't seen before. Let's try our model out by generating predictions on 2 images of leaves. As someone who's not a plant expert, I'd probably classify both of these as leaves, or if we're being very technical, green leaves. Let's see what our model says. Turns out these both belong to different species, and our model was predicted both varieties correctly with over 96% confidence. Once we have a trained model, AutoML gives us access to a custom REST API endpoint to make predictions. If I add more images and train a new version of my model, I only need to change the model ID in my API request. I am incredibly excited about AutoML because it gives anyone the tools to build custom models, regardless of their machine learning expertise. You might even say that AutoML Vision is turning over a new leaf in the way we build image classification models. And although I've shown plant species classification here, you could easily build a model in any other domain. We've seen our alpha users build AutoML Vision models for identifying damaged products before they're shipped, classifying catalog-specific images, and identifying points in time, like stages of construction. But what about other kinds of information, like text documents or news articles? With AutoML natural language, it's just as easy to build a custom model to make sense of written content. Take DonorsChoose.org, for example, a nonprofit that receives hundreds of thousands of proposals each year for classroom projects in need of funding. They currently rely on a team of volunteers to manually screen each submission. So they published a data set to Kaggle in hopes that a community of machine learning experts could build them an automated solution. Let's see if AutoML natural language can help. Similar to AutoML Vision, here I can look at all of the examples in my data set and their corresponding label. The text inputs to our model are need statements from the teachers, detailing the materials they need for their classroom. Each need request has an associated category to help direct the teacher's request to a relevant donor. The labels used to train the model have been assigned manually by volunteers. Once the model is trained, it'll be able to predict the category of new requests automatically. To see how our model performs on new text that hasn't been categorized yet, we'll take the following need statement as an example. My students need aquarium lighting for our environmental clownfish aquaculture project. DonorsChoose needs to assign the category lab equipment to this request, which isn't completely obvious from the text itself. Let's try it out on our trained model. We can see that our model was able to correctly classify this as lab equipment with 98% confidence. Like AutoML Vision, I now have access to a custom model that I can use to generate predictions on new text with one API request. That's really all there is to it. Without writing any model code, you can build custom machine learning models that can accurately recognize your own images, understand the contents of your documents, and even translate your jargon authentically. They're ready to use immediately, accessible through Google Cloud, and they scale automatically to meet your needs.